But just for the fun of it, I'm going to show you something that I like to play with every now and then when I get bored. It's a little, well, it's basically a little string with magnets. That's basically it. I'll show you the bottom part of it. There's nothing special to it. I mean, and don't confuse this for any sort of perpetual motion machine or anything like that. That's definitely not where this is going. It's just having some fun with magnets. My original idea was just to get some sort of oscillation going, just to see how long I can get motion in magnets. But you know, originally the idea was at least, and I will still continue with that, is to have heat generated at the top with ferrite magnets in between. Let's say a ferrite magnet at the top, heated up. As soon as it gets contacted, this thing falls down every time. So you know, just playing around a little machine. I mean, obviously it's going to take a lot more energy than you know, whatever it will provide. That's not the point. It's more just to have fun with it. But the funny thing is, I just want to show you some of the cool things that you can do with this setup, right? I mean, so it's all, so okay. We'll just basically get started. I'll connect those two up. You see. I mean, okay, remember, there are no external, there are these magnets here at the side, but I'll use that for now. It's not really what to see about. But anyways, so okay, let me get started. I always get stuck playing with stuff. First thing you'll need is to get those the magnets connected on this line. It forms a very specific formation. If you do this, it makes like a little V shape on both sides, providing a little bit of a wedge through it, but not enough to provide a lot of friction on it. So I'll show you basically what happens with it. So I mean, at the moment you can see this direct reaction between the two sets of magnets. So I'm just going to connect this side up here. Let's see. I want to connect this maybe possibly like that. Connect this one at the back side. And so now we've got the first little interesting thing. You know, I mean, this thing will go on for quite a little bit of time. But if we really want to see the interesting part, okay, let me first explain. Now, first of all, there's a magnet. Okay, I mean, obviously two magnets in a situation, right? I mean, we've got effectively a big magnet and a small magnet. Because of a wedge in the line, it's literally a fish line. Yeah, because of a wedge in a fish line, it forms is a little bit of friction to keep it in place. Right? When one magnet spins, the other magnet at the bottom, you can imagine it like a rope. If you twist the rope, the magnet, the rope at the bottom will also want it to go alongside. But now you've got some weight attached to it. You know, there's also a wedge at the bottom of this, you know, at this magnet. There's also a wedge. So there's some weight with it, and there's a delayed reaction. So you know, it's not immediately that, it doesn't immediately transfer that energy down the line. So the difference between this difference is what causes a little bit of a delay, because I mean, the magnetic force is pretty much instantaneous, right? But the effect of the shear or the twist of the fishing line is what causes the additional delay. So there's a difference in time basically in that sense. So what happens then is, now when one magnet is at one position, it will push the other magnet, you know, it will try to push the other magnet away basically, right? But as soon as it pushes the other magnet away, there's already again a twist in this wire, in the fish line, which now causes once again delayed reaction. So you'll see, for example, you'll see this is not very symmetrical or not very natural. You'll see you can see a direct reaction between the two. As the one goes to the side, you'll see it wants to come back, and then there's a little bit of a shift as the other one tries other magnetic field passes through and tries to shift it. And then there's this tug of war that's continuously happening. Okay, there is an entropy involved, which means effectively at the end of the day this will run out and stabilize to a equilibrium state. But just to have fun with the idea, there are a couple of things that you can do. But one of the coolest things is really just to see it in full swing, in action. It's basically literally full swing. So I'm just winding this up a little bit. And as you can see, the bottom magnet wants to follow. There's no real friction. I mean, this thing spins freely. I mean, I can hold it like that. It doesn't really want to spin back. There's enough friction to keep it in place, and there's enough friction to cause the bottom magnet to spin as well, along with a magnetic field, which just eases the tension, if I can say that. And now, well, I'll speed it up a little bit, and okay, now this is the magic moment, basically. Well, let's give it another one. Here we go. Right? I mean, even at that point, there's fairly little tension on it. Right? And now here we go. Well, and you'll see some funny stuff coming up at the end when you'll think, oh yeah, it's stabilizing now, but you'll see when it gets a little bit of a spin again, you'll see it maneuver. I think the camera is a little bit slow to catch the bottom one, the bottom magnet's spin. Okay, so now at the moment it's coming to a stabilization, but not quite. You'll see there's quite a little bit of a wobble still left at the bottom one. They're equalizing now, and then we'll come out of equilibrium, and then back in and out, or not equilibrium, but in synchronization. But okay, well, we can add some magnets to it, or we can make it interesting. I mean, this will go on for quite a while. There's not a lot of friction on this. I mean, I'll put the stopper in here right now, so we can just see basically what. I mean, so yeah. So if we put something like this is magnetic, so it will cause it to do all sorts of movements. Now, if we just give it a little push, it should get. Okay, well, it's too much. It's too much of a push. Anyways, there's quite a lot of things, or cool things to play around with, especially if you bring in ferrite magnets, or you bring in some different shaped magnets. Because remember, this field, this magnetic field, it plays a large role, the shape on how it will actually rotate. So I mean, if we take some of these, I'll show you. I'll use the camera right over here. I mean, we can take some of these rectangular magnets and add it to it, and this will change the fields. Will get rebounded at. So we'll just take a couple of these and just add it to say the top one. Right, and or we can do the alternative. First of all, let's do a test of pushing it away simply, right? I mean, you can get enough friction. Let me do it from that side. So I mean, just playing around. I hope I'm not wasting your time. then you can always do some funny stuff. Well, just want to get it connected to that side. Then, well, if we spin it up now, it's going to go really fast. Well, so again, then we'll say, well, why do that, right? And let's add some more. This isn't going to be that secure, but we'll add it in any case. So, I mean, shit. It's always just funny to see how delayed traction. So let's give us a nice little spin. I mean, the camera is quite slow. So yeah. Well, yeah, you see that. Should use my other little trick. Thing is, a big important part to keep it, to stop it from jumping off here. You need to get it threaded through, and also obviously not. I mean, if you do it at the right, just the right distance, you won't get that problem. I mean, like over there, it should be fine. But okay, let's get this spin going. Let's do this part. That off there, and let's maybe do something like this. Right. So put some friction on that. Let's see what the hell happens, right? So this one at the top, well, it doesn't really want to move. Shit. I don't know, I get to play with these magnets way too often. I guess there are people that don't get to play with it, so I'll just show you. I mean, that's just some of the beauty in life. So yeah, I wonder if there's a challenge for not really going perpetual motion, but I mean the question is, how long can you really let this go on? The smallest amount, relatively, the smallest, let's say kilograms of, or let's not work in kilograms, smallest number of grams of N30, N52 new diamond magnetic material. In what shape do you need to place it and where to get the longest oscillation going through the system? Because I mean, this is still going, it's obviously quieted down quite a lot. There's a lot of magnetic friction, if I can call it that. I mean, this pushes back on that, pushes back. So it's not the best in that sense, but it's also very effective. If you slightest change over here would make a big change on that side. So I mean, it's, well, kind of like mechanics, I guess. So let's see what else can we do. Some ferrite magnets, we can add some small magnets. I mean, let's see how all this works. Don't think this is going to work, and the system can collapse at any second now. Right, and I will do. Okay, I need to be careful of. Just one strap. Opposite. Botha. Yeah. Yeah, so anyways, so, I'll leave it as it was. So, wait, so, anyways.